Good morning. We're going to graph trig functions today, and we already know the main characteristics of a trig function, the amplitude, period, midline, and then also something we need to consider is our horizontal shift, which we call the phase shift or phase displacement. Okay, and basically that's when the inside input part, so right here, b times t minus d is equal to 0. So it's just how far over the beginning of your cycle is shifted. Okay, so we're going to graph without phase displacement today, but I am going to show you how to find how far shifted the graph is. All right, so here we go. We're going to pick out our midline. Our k value is -2. Our amplitude is the multiplier outside the function, so that's +2. The period, let's see, it looks like the frequency is 1 because it's 1x, so the b value is 1. So 2 pi over 1 would give me a regular cycle of 2 pi. This is for one cycle, okay? And then the phase displacement, we take anything inside the parentheses. So I take x and equal it to 0. So this function has been shifted 0 units left or right, okay? All right, the next thing we have to do is figure out how to graph the increments. So there's 5 main points in a sine function. It is the mid, I'll put it over here. So it's going to be the midline, the high point, the midline, the low point, and the midline. So I need to figure out what each one of these x increments are. So what am I counting by, basically? It takes me 2 pi to complete one cycle. So and I start at 0. So I'm going to start at 0 because that's where because my graph has not been shifted left or right. And then I'm going to take my 2 pi because it takes me 2 pi to get to the end of my cycle. And I'm just going to basically divide it by 4. So 2 pi divided by 4, it looks like I can reduce by 2, giving me pi over 2. So I'm going to count here by pi over 2, or 1/2 pi. Okay, so I get 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And I just seriously just count up 1, 2, 3, 4, and let the denominator stay the same. And then afterwards, I'm going to reduce. So I see that I can reduce 2 pi over 2 to just pi, and 4 pi over 2 to 2 pi. All right, so now I'm going to use those to label my graph. So it'll be like, that is 0. That right there, I'm going to go every other line is pi over 2. That is pi. 1, 2 gives me 3 pi over 2. 1, 2 gives me 2 pi. And since I have to do 2 cycles, I'm going to go backwards as well. So I'm going to count backwards. Negative pi over 2. 1, 2. Negative pi. Negative 3 pi over 2. And negative 2 pi. All right, so one cycle of now I'm going to go ahead and graph in my midline, my amplitude, and my amplitude. That's what I'm going to do. Okay, so the midline is at -2. I'm going to graph 1, 2, and I just sketch it in right there. Okay, at y equals -2. My amplitude is +2 from the midline, so -2 plus 2 would give me 0. So I graph up to 0 and down to -4. Now we have a sine graph. Sine starts at the midline, and the amplitude is positive, so it's going to go up from there. Okay, so I'm going to go with, let's go with like red. Okay, I'm going to start at the midline, and I'm going to graph to the high point or my upper bound, and then we're going to go back down to the midline at pi, back down to the lower bound, and then to the midline. Oops, I'm off by 1, to the midline. This right here is our sine graph, 1 cycle. We need 2 cycles. So I'm going to go ahead and go backwards. Since I am starting from up, I'm going to go down to the lower bound, midline, upper bound, lower bound. Okay. So lower bound, midline, upper bound, lower bound. Okay, imagine yourself going around in the circle now. And draw yourself a circle here. Okay, if I were at time 0, I would be at the midline of the circle. The midline of the circle. At time pi over 2, you're at the highest point of your graph. Time pi, back to the midline. Look, see the midline? Okay. Time 3 pi over 2, right here. You're at the lowest point of your circle. And then back to the midline. Okay, so that's what we're modeling here is the height. The sine is the height of the units of the circle, basically. Okay, number 2, midline. Give me all the things. Okay, so the midline is at 3. The amplitude is -1. Technically, the amplitude is the absolute value, so it's +1. I'm just going to remember that because it's cosine, we're going to start on the lower bound because it's negative. We're going to start on the lower bound. Okay. The b value is 1. So 2 pi over b would give me 2 pi over 1, which is 2 pi. So our cycle is 2 pi. The phase displacement, anything inside the parentheses. So we're going to do x is equal to 0. For the inside the parentheses here. So we're going to start, always the beginning of the phase displacement goes at 0. And then I need to add the period. So I'm going to take the period, 2 pi, and divide it by 4. I always do this, no matter what. All right, and that reduces to 2 pi over 2. So that tells me I'm going to add half pi every basically every quarter of my graph. So I'm going to add 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. This one doesn't reduce. 2 pi over 2 is pi. 3 pi over 2 doesn't reduce. 4 pi over 2 gives me 2 pi. I'm going to check the distance between 0 to 2 pi. That should match the period. Does that match the period? Yes. Okay, so this is a total distance of 2 pi, which is equal to the period. Okay, so again, we're going to graph in our little increments. So 0, pi over 2, or half pi, pi, 3 pi over 2, and 2 pi. Going backwards, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. All right, midline and amplitude are next. So midline is at y is equal to 3. So 1, 2, 3. Go ahead and graph that in. Okay, amplitude is plus or minus 1 from the midline. So up 1 to 4 and down 1 to 2. All right, so we have a cosine graph, which normally starts at the high point, but because the amplitude is negative, it's a reflection down to the low point. So I'm going to start my cosine graph from the lower bound. We're going to go up to the midline, to the upper bound, midline, lower bound. So one cycle of my cosine graph I can see takes, I'm going low point to low point, so it takes 2 pi to complete one cycle. I'm going to graph backwards, midline, upper bound, midline, lower bound. Okay, and that is 2 cycles. So I have 1 cycle here, and then my next cycle is here. Okay. Number 3. Okay, so midline is -1. Amplitude is 3. The period, this time our b value is 2, so we're going to take 2 pi and divide it by 2, giving me pi. Our phase displacement is 2x is equal to 0, so divide by 2, x is equal to 0. So I'm going to start at 0, and it should take a total of pi this time. Okay, so let's take pi divided by 4. It tells me what to count by. So this doesn't simplify, so I'm going to go ahead and say, I'm going to start counting up. Pi over 4, or this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and these reduce to, let's see, 1 pi over 4 doesn't reduce, 2 pi over 4 reduces to pi over 2, and then 3 pi over 4 doesn't reduce, and 4 pi over 4 reduces to pi. So I always reduce after I write out the increments, because I notice that sometimes we have a difficult time with fractions. Okay, so next is to write our our scale, basically. So 0, the next is going to be pi over 4, the next is going to be pi over 2, 3 pi over 4, and pi. The midline is at I didn't count backwards. The backwards, we're going to go negative pi over 4, pi over 2. So this graph is going to look really similar because we stretched out our scale. But notice that the distance between 0 to where we were graphing before, to that second to last tick mark, is only a distance of pi now. Okay. So k is equal to -1, so I'm going to go ahead and sketch in my midline at -1, up 3, 1, 2, 3, to y equals 2. That's my upper bound. Lower bound at 1, 2, 3, -4. All right, do we start midline, high point, or lower bound? We're going to start, because it's sine, we're starting at the midline. We're starting at the mid, and we're going up, okay, because it's positive. So midline, upper bound, midline, lower bound, midline. Again, one cycle. Let's graph our second cycle, going backwards, midline, lower bound, midline, upper bound, midline. Okay, done. Next example. Okay, midline, 3, amplitude is 4, period. This time our b value, our frequency is pi, so we do 2 pi over pi. That's nice. The pi's cancel, giving me just 2. Phase displacement, pi x is equal to 0 divided by pi. 0 divided by pi is 0, so I get x is equal to 0. Again, that's where we start from, at 0. And then I take the period, which is 2 this time. This is the period. And we split it into quarters. Okay, so 2 divided by 4 gives me 1/2. All right, so we're just going to count up by halves. So 1/2. We're going to add 1/2. That's 2 over 2, 3 over 2, 4 over 2. 2 over 2 reduces to 1, and 4 over 2 reduces to 2. All right, so we're going to count 0, 1/2, 1, 3/2, 2, backwards, -1/2, -1, -3/2, -2. Midline, 1, 2, 3. Amplitude, up 4, 1, 2, 3, 4. I'm going to add a couple lines there. Sorry about that. down 1, 2, 3, 4. Okay, so the radius is really big. The circle is stretching really far up and going really far down, okay, because of the amplitude. All right, cosine graph, positive cosine graph. We're going to start at the upper bound when x equals 0. First quarter, we go spin to the midline, the lower bound. 2, 3, 4. Okay, I did count right. The midline, then the upper bound. So one cycle of the graph, relative maximum to relative maximum, takes us a domain of 0 to 2. So a total of 2 units. Okay? So we're going to go midline, lower bound, midline, upper bound. Look how pretty they are. Okay, last one. Midline of 1. Amplitude is the multiplier at -2. The period, the b value is 1/2, so the period is 2 pi over 1/2. Okay, multiply by the reciprocal of 2. The bottom cancels, giving me 4 pi. All right, phase displacement. 1/2 x is equal to 0. Multiply by the reciprocal, giving me x is equal to 0. Okay, we're going to start at 0. I need to take the period, which is 4 pi, and divide it by 4. Oh, you know what? The multiplier in front of x is 1/2, which tells me it's the speed that we're moving. So if I walk half as fast going home, how much time is it going to take me? It's going to take me twice as long to get home. So your cycle, instead of taking 2 pi, is going to take 4 pi to complete. So we're hitting the same landmarks, but taking a lot more time to complete the distance, okay? So 4 pi, back to this. 4 pi divided by 4 that cancels, giving me 1 pi, or pi. Okay, we're going to add pi, add another pi, giving me 2 pi, 3 pi, 4 pi. Check. Is the total domain, the distance between 0 to 4 pi, 4 pi? Yes. It's nice because it starts at 0. That's what happens when we don't have a phase displacement. Okay, counting on the axes. 0, pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Do you always have to skip 2 lines right here, like, 1, 2, 1, 2? No, I just do it because it makes it easier for me to write in the numbers. But if you want to squishy up the graph, that's okay. All right? Yeah, that's fine. Okay, midline at 1. Amplitude. We're adding 2 and subtracting 2 from the midline. Okay, sine graph tells me that we start at the mid, and it's negative, so we're going to go down first. Okay, so we're starting at the midline. We're going to spin down at x equals pi to the lower bound. At 2 pi, we're at the midline. 3 pi, we're at the upper bound. Top of the circle. Back to the midline. One full cycle of your graph. It looks like sine, but it's been reflected over. So the high points become the low points, and the low points become the high points. All right, one more cycle of sine. We're going to go up, mid, down, mid. Again, the low points became high points, and the high points became low points with the negative amplitude. That's it. I'll have one more video about delta math.